So this is question number 2.2 of class 12th, okay, class 12th, and the chapter name is electric potential and capacitance. So first of all, let's see an overview of this chapter so that you will going to revise it in every video. So it is going to be stuck in your mind that what you have to study in the this chapter, right? So first of all, in the first section of this chapter, we study about potential. Then we study in this two section about potential energy, and then in the end of this chapter we study about capacitance. So this is the three topic that is in this chapter, and in the three chapter it will going to be finished, right? And particularly this question, the question that is given of hexagonal having a 10 centimeter of side, charge containing each vertex having 5 microcoulomb, and they have to calculate the potential at the center, right? So this is the question that is arises from this 2.5 particularly, and the concept is q1, q2, q3, q4, and the potential total at this point p is going to be the sum of the equal potential due to all these individual charges, that is v1, v2, v3, v4, and if the distance between is r1, r2, r3, r4 between the point and the charge. So the potential for each v1 you can write as v1 is equal to k q1 by r1, that is that charge magnitude of the charge by distance between the charge and the point. Okay, so this is the concept. So v total is going to be v1 plus v2 plus v3 plus v4, right? So this is the concept, that is not so hard. Let's now solve this question that we have, right? So the question says, given that, first of all, right, the way you have to write this in your exam, I'm going to write it this way. So given that the side of hexagon, regular hexagon, that is 10 centimeter, means 0.1 meter, and the charges at each vertex is going to be 5 microcoulomb, that is equal to 5 into 10 to the power minus 6 coulomb. Okay, now let's visualize this figure, and by visualizing you can see that what is happening here. So this is a hexagon that you have, this is a hexagon, okay, and you have q charge at each vertex, right? And at this point p you have to show that what is the total potential at this point p. So first of all, for that you have to particularly figure it out that what is the distance between this charge and this point. What is this r, right? What is this r, what is this r, what is this r, what is this r, and what is this r. Then you are able to find that what is the charge or the potential that is individually exerted on this point p due to every individual potential charge, right? So you have to find this r, and by symmetry you can say that this all r is going to be same, right? And also you can prove that by visualizing or by direct using formula for the interior angle of a polygon. This is the interior angle of a polygon. How you deduct the formula for a interior angle of a polygon? How you deduce? So first of all, you write the interior angle is equal to n minus 2 by n into 180 degree, right? You have heard this formula in your 9th and 10th. Now the n is going to be the side of the regular polygon. Here the side n is 6 minus 2 by 6 into 180, and that is going to be 4 by 6 means 2 by 3 into 180, and that is going to be 120 degree Celsius degree, right? So the interior angle is going to be 120 degree, and this 120 degree is divided equally by this distance r, right? So this side is going to be 60, and obviously this side is going to be also 60, and if this two side is 60, that means this is also 60. So this is equilateral triangle, means this side if 0.1 meter, that means this is also 0.1 meter, and means this is also 0.1 meter, right? So you have understand that diagram. Okay, this is not so hard, right? Now we have to apply the formula or the concept that we have. What is the concept? The total potential, the total potential, TIAL, sorry, the total potential at point P is sum of all the individual potential due to each charges, right? So this is what you have to write. This is what you have to write, the concept. Now only the solution part is remained. So in solution, what you have to write? Vt is equal to v1 plus v2 plus v3 plus v4 plus v5 plus v6. v1, v2, v3, v4, v5, v6. What is it? v1 is the potential that is exerted on point P due to charge q1. Let's assume this is q1, and it don't matter because every charge is of equal magnitude and of the same symmetry. That means all the charges is going to be same, q1, q2, q3, q4. And also the r1, r2, r3, r4, it is also symmetry and same. That means r1 is equal to r2 is equal to r3 is equal to r4. So by symmetry you can write, first of all write that formula for each. So k q1 by r1 plus k q2 by r2 and so on you can write. And by symmetry you can say that q1 is equal to q2 is equal to q3 is equal to so on, r1 is equal to r2 is equal to r3 and so on, right? So after putting the values, or you can say that v total is going to be, because every term is same, that means you can write 6 into kq by r, right now. So now what you can write for vt is equal to 6 into the value of k, the value of k is 9 into 10 to the power 9, right? And q is going to be 5 into 10 to the power minus 6, and the value of r is 0.1 meter. And if r you have taken the decimal, it is going to be into 10 upside, right? So this is going to be 9 5s are 45 into 6, that is 6 5s are 30, and 6 4s are 24, 24 25 26 27, means 270. 270 into this 10 and this 10 to the power 9, that means 10 to the power 10, and minus 10 to the power into 10 to the power 6, that means 10 minus 6 is going to be 10 into 10 minus 6, that is going to be 270 into 10 to the power 4, and that is equal to Vt is equal to 270 into 10 to the power 4, and you can write this value as Vt is equal to 2.7 into 10 to the power 6, and the unit of potential is volt, right? So this is the answer that you're going to get, right? So this is your correct answer.